So, where was I? I spoke about decision as a fundamental foundation of SRE work. Whatever you do, whether you are automating, you are solving the problem, you are conducting prognosis or diagnosis, decisions. Quality of decisions is going to be very important to make you successful. Am I right? Now, as I said, the very advantage of cloud, the very strength of cloud or distributed architectures, they become, for example, we talk about automation and agility. The very automation causes abstraction. When I automate everything around me, I don't know how it is working. So I may take some decisions which are suboptimal or harmful, right? Then you have scalability. Scalability can cause cost escalation, elasticity. Then you have what? Shared responsibility. You have shared responsibility could cause complete confusion. See, anything you take as strength in cloud or distributed architecture, see, we exist because of distributed architecture. SRE wouldn't be required if everything is monolith, predictable. Unpredictability, uncertainty, and indeterminism, and you have to make decisions, you have to make trade-offs. Whether it is designing or reconfiguring, it's all trade-off. Throughput, latency. Performance, security. Everything has a balance. You can't say, I will build a very high performance system, highly secure system, highly customer friendly system, high latency, high throughput. You can keep all your life, you'll be designing that system. At some point, whether it is requirements or design, you have to make choices. So SREs have to make decisions under uncertainty, because I don't know what is the consequence of what I am deciding. I don't think I'll be able to complete my entire lecture today, but get this first and we can have a conversation later, because the topic is so vast. I want SREs to start to think system approach. I'll explain to you what is system approach. System approach is taking into account all the factors. First is modeling the entire thing as a system, not as a small queue management or VM management. I am VM manager. Oh, you are an SRE system, right? So you have these trade-offs, right? So the world of VUCA, what is world of VUCA, right? Volatility, uncertainty, complexity, and ambiguity, right? So for example, you take, I said, scalability and load balancing, for example. Load balancing is good, but often load balancing convicts certain machines if the machine is slow. And if all the machines are slow because of some reason, the entire thing becomes convicted as unhealthy and aggravating the problem. So sometimes solving the problem can cause the problem. You see this? Can you realize that? Can you recognize that symptom in your work also? Sir, I'm solving a problem. Boss, you have solved the problem, cause more problem.
That becomes another single point of
Exactly. There is nothing like a single point of failure in distributed architecture. Believe me, it's all a collection of symptoms, like a mob mentality. Mobs, when the mobs come, no, what can you do? Take a gun? You can't. You have to only run. You can't control mob. But this is a good mob. This is a useful mob. So, see, diagnosis, predictions, or let's take diagnosis. If there is an anomaly, is that anomaly transient failure or permanent failure or no failure? Uncertainty. If you go and intervene when it's only a transient failure, you're going to actually cause more problem. Similarly, predictions. The earlier the prediction, can you progress it? The earlier the prediction, the better for you. But the earlier the prediction, more uncertainty. If I want to predict rain in the evening now, more useful. But you can't be sure. So, umbrella problem. When you don't carry umbrella, it rains. You seen this? So the earlier, more useful, but more uncertain. Now you see your challenge. So ask for a pay hike tomorrow. Sir, I am conducting very critical decisions under uncertainty. Please keep moving, it's not working. Because I have quite a few. Right? Now, your IT domain is so multi-dimensional. Your business domain, technology, application data, move. Application data, go back earlier. application data, then people, governance. So any decision you take in any one domain has a cascading impact on another domain. Every code will work, everything will work, but could violate a compliance clause written in some document somewhere. Or a business strategy is changing, where all you have to modify, you don't know. So, this is where last SRE I spoke about this, how you take insights from multiple tools. Now, you may ask me, Mahesh, you told me about cognitive load on SRE. How do I do it now? You're only complicating my job. You told me observability is actually creating flood of data. You are asking me to look at all these tools. This is where GenAI helps you. GenAI is best put to use if you understand the problem. The problem definition is, how do I take multiple tool insights to solve a problem? So since I am short of time, see, we had an issue with an e-commerce company wherein the checkout was getting delayed, inconsistent, out of control. Sometimes it is okay, sometimes not okay. And what do we do? The usual suspects. Have you seen this movie, Casablanca? The last scene, no, it says the usual suspects. Means we know what are typically, what three things the SRE does when there is a problem: either kill the process, or restart, or increase the resources. Increase. Problem solved. No. Underlying problem won't be solved. It is like taking paracetamol for all kinds of fever. Your fever will get subsided, but what will happen to your liver? One problem, one solution, right? I get. Okay. Now, finally, what happened? The problems was not a single cause. It was a network of problems. There were hidden, because the company grew through acquisition, there were some hidden gateways, payment gateways. And some transactions were going through those gateways. Multiple databases, customer databases. API contracts were not properly written. As SRE, do you look at contracts? What happens if the contracts aren't written properly? Throttling. Throttling happens. The throttling happens without your knowledge. You will think there's a problem with your code. And there were issues with business process design. Extra validations are happening for customer data because the address had to be validated before sending it to the external API vendor, external API providers. Geographical address had to be validated for shipping. And then there were, I say, data lineage issues. Data was getting ingested at multiple places without validation and getting combined, non-synchronized, apart from the usual problems, which is code optimization and all that, right? So the best way, so because I don't have time, I cannot go through. Another issue was re-authentication unnecessarily, multiple re-authentications before the actual payment was going on to detect fraud, right? So the best thing to solve this problem is using GenAI. Now I stop here because for GenAI you need a vector database, you need prompt engineering. Now, what I have done till now is I have introduced you to the problem, complexity of the problem, and we have hopefully agreed that most problems which are critical aren't simple root cause problems. They are much more complex. They need a more omnifunctional, multidimensional data to solve it. Best way to solve it is to use GenAI. Because GenAI, you can start to create prompt and create a module, a prompt module, so that it starts to reason with all the tool inputs. To the vector database, the knowledge base, you can add more and more tool outputs. Celonis, business process. How many of you have used Celonis? Aptio, Colibra, Dynatrace, ServiceNow, GitHub, source code repository. Everything can go into it because it starts to correlate everything. You made a change 3 weeks back. That change has caused product recommendation module got changed. Even the product recommendation module has no connection with checkout, they are sharing the same infrastructure. Product recommendation module is hogging resources because it got enhanced. You have no way of knowing this, right? Now, let's go to proactive approach. Here is where MIT stamp comes. MIT, right? They have defined a beautiful, very useful framework. One Professor Nancy Levison. I go talk everywhere about this because I just love it. I have used it, it's so useful. System, because a system thinking and approach, you need a framework. I spoke about reactive. When you have a problem, how do you solve it using GenAI? But how do you avoid it? How do you apply system approach proactively? The STAMP stands for System Theoretic Analysis. Just search Google, MIT stamp, because I used it so much I forgot about it. System Theoretical Accident, just search MIT stamp. Even morning I revised it. Yes, exactly, right. It was brought in for air accident because our cloud systems are very similar to air accidents. Those of you who followed the 787 crash in Ahmedabad, you'll be amazed to know what is the current root cause or the causal network. Somebody said pilot suicide, somebody said something else. You can talk to me later. I'll tell you how insightful applying system thinking and how to avoid it. Today what happens? They will say pilot mental health, fuel contamination, this, that, this, all that. How do you put it all together? So SAMP helps you in. The system is not a sum of its parts, like body, right? Body is not sum of liver, kidney or heart. It works in a very integrated whole. Every part, if you call it a part, works with other part in a very coordinated way. You can't say body is a sum of liver, kidney and all that. Similarly, any system, any distributed architecture is not just a sum, it is much more than that, right? The interactions between various components could be very beneficial, could also cause serious issues, right? Okay, so in STAMP what we do is, we model it as a socio-technical system because you are part of the system. It's not that you are different from the system. Socio-technical system, your organization, you, including your boss, and the system. Everything is modeled. What's a model, right? A model means a representation of a system, of something, right? So what we do here is, very important part of STAMP or STPA, STAMP has got two, CAST and STPA. STPA is for analysis, CAST is for post-accident review, post-accident root cause analysis, right? STPA is what we are using here. So what we do here is, here we believe that every system has to have a control structure. The control structure doesn't have to be separate, but within the system, you have to start to think about controls, right? And then it's very commonsensical. First, what we do is, this is just I will send you the slide here. This is a comparative, because many people may say, I've got chaos engineering, why do you want a new thing? I've got observability, I have incident analysis, I have resiliency testing, I have performance engineering. This puts it all together. So I would recommend you to read up STPA STAMP and then see how you can apply it. I'll show you a demonstration of this. So in this, what we do here is look at, the first identify stakeholders. Very simple, but very profound and very powerful. Stakeholders. Who are the stakeholders? You, your organization, customers. Identify the stakeholders. And identify losses. Losses here doesn't mean loss of life or anything. In STAMP terminology, losses means anything that a stakeholder does not wants to avoid. So you can here I modeled it, the e-commerce system analyst, financial loss, customer attrition, damaged reputation, legal penalties, all that, right? Now, after you have identified losses, you identify hazards. Hazards are not exactly accidents, but they are events or situations which can lead to losses. Like a security breach, not necessarily a loss yet, could lead to loss. Like a ice on the road. In Chennai, you will never get ice, okay? Chennai roads themselves are very hazardous. Okay. correct? But then we live with the hazard here, right? So probably it's not a hazard anymore now. So I've identified some hazards here, data inconsistency. The loss hazards could lead to losses. Now once you have identified the losses, we look at loss hazard mapping. Simple. What hazard could lead to what loss? Then now we come to system constraints, which is your non-functional requirements. We don't start with non-functional requirements. We look at the stakeholders, the losses, the hazards. Most likely the hazards flipped will be the non-functional requirement. System is unable to provide essential services during peak traffic loads. Then most likely most of them are your performance specifications, cost specification, cost of resources, latency, throughput, security, availability, resiliency, reliability. These are non-functional. I never understood why we call them non-functional. It's so important. I would call it operational quality. Somebody says non-functional, you can scold them now. Why you want to call it functional, non-functional? Huh? You don't say my car has got excellent non-functional quality, performance, non-functional quality. How can it be? Okay, so we have done this, right? We came to hazards. Now, stakeholders, losses, hazards, constraints, then we create a control structure. In this particular control structure, logically what could it be? Control structure, how much time I have? 5 more minutes? 3 minutes? Control structure, 3 levels. Application level control, which is your application, what do you call? Patterns, circuit breaker pattern, heard of all that, right? Then at the configuration level, what are the controls, right? Then you have the what are controls at your level, right? Now having done this, we compare what are those 3 levels of controls, and then we create a control loop, control and feedback. Feedback is primarily observability. Now observability exists as part of a larger system level approach rather than an end in itself. Observability is not the end in itself. It should be made as part of a controllability structure. Otherwise, what do I observe? I keep observing whatever I want to observe, right? So, now I identify loss scenarios. Okay, since there is no time for it, I have to rush through this. So emergent properties are what? Emergent property is a result of the complexity. So see, we cannot control performance. Performance happens because of the consequence of the design choices. Now, that's the reason why performance, latency, throughput are all sometimes very uncontrolled. With a stamp approach, you can start to at least be better than what you are today. Because at every stage, you are controlling it, right? So from this, we found we had lots of findings through a STP stamp approach, which is primarily availability zone problem. For example, availability zone. When the switchover happens, don't assume things will bring up quickly, right? It takes time. But often developers and configuration engineers assume that availability zone switchover will ensure continuity. It doesn't. So not that you don't know it, stamp STPA will force you to think in those lines. Okay? Then this is the benefit we got: mean time to recovery, incident rate improvement, latency detection of latency issues, operator recovery error rate, and then customer drop off during failures. So to summarize, think system, think uncertainty, accept uncertainty, respect the distributed architectures, power and risk, right? Take into account all the outputs from all various tools that are today available, build expertise in all those areas. Not necessarily you have to be expert in Colibra or Lean IX, enterprise architecture or Celonis. Output, put them, synthesize the outputs, analyze using GenAI, and then use system thinking approaches. Then all that you spoke about will make more sense. because it's in a context of a larger system. Thank you so much. Look forward to discussing with you. Thank you, Mark, for the opportunity. Wonderful always being here with your presence, majestic presence. Okay. Thank you very much.